Hello everyone, welcome to my channel. Here is new video for inserting objects along polyline. It's a continuation of our previous videos. In this video we are going to create the macro to insert objects. Here we will search for the polylines in the drawing and insert card points along the polyline for given spacing. So here we are not considering about other objects or blocks or anything, just only card points. Then later on we will add additional objects or blocks or text or anything and insert using user form. Here in this drawing we have a polyline with 6 vertices and 2 curves, one in counterclockwise and the other in clockwise directions. Now come to Excel VBA. Use the same Excel file we used to create the function. First we will move this function which we created before to a new module, just to avoid mixing up with our new procedures. Insert a new module and rename it, then copy function to it. In the main module we will create a procedure first, sub main. In this procedure we will set our drawings and search for the polylines. When we find polylines, we will go to next routine to find the segments. So we create another procedure to find segments. In this procedure we will go through each segments in the polyline and extract the x, y, z coordinates and budge value of the segment. Then if the segment is a line, then we will jump to another procedure that's only for line segment to calculate the insertion points on line segment. And if it is an arc, we will go to the procedure for arc segment to calculate the insertion points. So for each segment types we will use separate procedures. From the main we will select the polyline and we will pass the polyline to all the procedures and find the insertion point, and then we insert object using new procedure insert point. Now let us start by declaring our variables. First declare option explicit at the beginning. Don't forget, when you set up option explicit, you have to declare all variables to use in the macro. First we need the drawing object. Declare the variable outside the procedure so that it can be used for all the procedures. We need the drawing object to all our procedures. Public my drawing as a card document. Next we will go through each object in the drawing. So we have to declare a variable object as a card object. Next is polyline object. We will set if it is polyline, we will set the object to polyline. The P-line as a cut lightweight polyline. Then we are about the data to extract it from the polyline. First total number of vertices, that is dim but as integer. Next we need the index of the vertex. It's dim I as integer. Then for each segment we have two coordinate points. That is, we are considering when we are considering a segment, we are considering segment between two coordinate points, and we are inserting points. So we will get the coordinate 1 and coordinate 2. That is, dim coordinate 1 and coordinate 2 as variant. The data we extract from the coordinate is not an array data type. It will return variant data type. That's why we use the data type as variant. These coordinate points we have to convert into 3-dimensional array. So declare new variables start point and end point as 3-dimensional array. Here we are declaring only variables which is common for all these procedures. When it is a line segment or arc segment, we need these 2 points. Here we are Now declare variable for insertion point as a variant. We have an input from our side, that is spacing for the point. That's array spacing. Declare a variable for array spacing as double. After getting array spacing, now we need two variables, length of the segment and the length from base point to the insertion point. Okay. Declare segment length and length to point, two variables as double. Here each time we add array spacing to the length to point and then insert the point. So every time we measure the length from the base point, then we will measure the length to insertion point. So each time we will add array spacing to the length to point. And if the length to point is greater than the segment length, that means the next point is on the next segment. You can declare an object variable card point as a cut point. The remaining variables we will declare on the go. Now writing macro, let us go to the main procedure. Set the drawing object to active document. Here we forgot to declare another variable. In VBA, angles are calculated in radian, so we need pi value to convert angles. So declare pi as double, and here pi is equal to arc tan 1 multiplied by 4, which gives 3.14. Now we get the array spacing using an input box. Later on we will choose the user input from the user form. Now temporarily we are using input box. Now we will search through objects in the drawing. For each objects in the mydrawing.model space, if object name is equal to ICDP polyline, so here you must be careful about the uppercase and lowercase of object name. It's a string, so here case is meta. So if you don't know, if you are not sure about the object name, you can use a ucase function, change all to uppercase and write the name in uppercase. So now set the object to P-line. Let's say object name is equal to SDV polyline, set the object to P-line variable object. Here we will go to the next procedure to find the segment. Then close the if with end if and for loop with next. You can split the window here so that you can view the variable at the same time, so that if there is any confusion you can check the variable names. Now go to the find segment procedure. First we will find the vertex count. This vertex is equal to u-bound p-line dot coordinates. Here it is coordinates, not coordinate. Coordinate is only for a single vertex. Here we have 6 vertices, that is 12 values starting from 0 to 11. So u-bound coordinates minus 1 divided by 2. That is the index number of vertex or segment starting from 0. Now we will loop through the vertex. For I is equal to 0 to, here total number of segment is less than the total number of vertex. So no need to go to till the end. So the last one is less than the maximum number, that is -1. Assign coordinate points. Coordinate 1 is equal to pline dot coordinate. Here it is not coordinates. We are using the vertex number. Pline dot coordinate I. The next coordinate is coordinate 2. Pline dot coordinate I plus 1. Now we will convert the variant to three-dimensional array. This start point and end point. We will use another variable k. Declare a new variable. For k is equal to 0 to 2. Close with the next k. Sorry, not k is equal to 2. We don't have a set value, so k is equal to 0 to 1 only. So start point k is equal to coordinate 1 and end point k is equal to coordinate 2. Okay. After the loop, we will assign z value from the polyline elevation. So start point 2 is equal to pline dot elevation and end point pline z value pline dot elevation. Let us provide some comments so that we will not confused. Go through the vertices. Now we will find the segment type using the bulge value. If pline dot get bulge index number I is equal to 0, then we will call the procedure line segment. Else we will call the arc segment. Now let us check the procedure. From the main, we will go through each object in the drawing. Then, if it is polyline, we call the subroutine find segment, and from the find segment, we will go through each vertices. Then convert the coordinates to start and end point. Then using get bulge, sorry, it is pline dot get bulge. If the bulge is 0, go to the line segment, otherwise call the arc segment. Now let us go to the line segment. To insert point on line segment, we use polar point function with the base point, angle and distance. Here base point is start point, angle is the angle of line segment, and distance is the length of point. First we will find the angle of segment. Declare a variable angle of line. We will use angle from axis function with the start point and end point. Now we will assign value for the segment length and length to point. Segment length is the distance from start point to end point. For length to point, each time we will add the array spacing to the length to point. For first vertex, length to point will be 0. That is, if I is equal to 0, the length to point is 0. Next is segment length equals. Here we will use distance from point function which we created before. from start point and end point. Here, if you are writing the if statement in a single line, end if statement is not required. So I remove the end if to reduce the length of code. Here we will use do loop, do while length to point is length to point less than segment length, close the loop. As long as length to point is less than segment length, we will find the insertion point using polar point function. Base point is start point, angle is angle of line, and distance is length to point. Now we will call the insert point procedure to inserting start point. Now update the distance length to point is equal length to point plus array spacing. Now we will verify the length to point again. If it is greater than segment length, we will exit the loop. Now we have to consider one more thing. Here in the drawing, if the vertex is here and the last point inserted is circle, and we don't have enough spacing in between them, and we want to keep the same spacing between the inserted points, then we have to deduct the remaining length from the previous segment from the array spacing, and that will be the next length to point. Later we will consider an option to insert point on the vertex. Now we will consider only array spacing. If the length to point is greater than segment length, then length to point is equal to length to point minus segment length. Here length to point will be 0 only if the vertex is the first vertex. Otherwise it will substitute the value from the remaining length. In arc segment we need more variables. Here for the line segment we declare only angle of line. Here first declare variable for total angle of arc, that is t delta. Then the angle of arc at the length of insertion point, that is d delta. Then arc radius, that is radius of the arc. Then the angle of radial line from the start point, that is angle of radius. Then angle of chord from the start point, that is angle of chord. The next center point is variant because polar point function turns variant at. Now assign the values. Total angle T delta is equals ATN P line get bulge index number by 4. That is the total angle of curve. D delta we will calculate while finding the insertion points. Arc radius is the half of chord divided by sine delta by 2. Arc radius is equals distance from points, start point, end point divided by 2, that is point multiplied by 0.5 divided by sine t delta by 2. Angle of chord is equals my drawing dot utility dot angle from axis start point end point. Angle of radius is equals pi divided by 2 minus total angle divided by 2 plus angle of chord. Let us put a command, assign values. Center point is polar point function. Base point is the start point, angle is the angle of radius, distance is the arc radius. First we will do the same as in the line segment. If I is equal to 0, length to point is 0. Then segment length is the radius multiplied by total angle. Next, the do loop. We'll do the same. Do while length to point is less than segment length. Close the loop. If it is less than segment length, first we will find the angle to the insertion point. That is d delta. So it is a length to point divided by arc radius. Now insertion point x value, that is center point x, minus cos angle of radius plus d delta multiplied by arc radius. Next is the y value, center point y minus sine angle of radius plus d delta multiplied by arc radius. Here we will call the insert point procedure to insert card point. After inserting card point, we will update the length to point. Now we will do the same as in a line segment. Just copy it and paste. Here length to point will be updated. Here we have to insert a point at the last vertex. Insertion point is equal endpoint, called the insert procedure. Now add code to the insert point procedure. Set card point is equals my drawing dot model space dot add point. There is only one variable, that is insertion point. Code is almost ready for a single polyline for a given spacing. Save the file. you didn't save. Now we can check for errors from the debug menu. Compile. There is error. Subcore function not defined. Here variable is not spelled correctly. Debug again. Again mistake. Debug again. Now syntax is correct. We can make a trial run. Select the main procedure. Make sure your cursor is on the main procedure so that it will run that procedure. Run the main procedure input box for array spacing. Enter the value. Now there is an error. Start point we used in the angle from axis is not valid. Click debug. Let us drag into the watch window. Here it shows as a variant data type, but it must be a double data type for angle from axis. Here data type assigned only for the last variable. If you didn't assign data type, we will consider the data type as a variant and it will consume more memory. Now let us assign the data types to all variables. I will run again. Enter spacing 5. Check the drawing. The points are inserted in the exact distance on the polyline. Now to check the orientation of curve, we will rotate the polyline in 360 degree. We'll use polar array. Now it's act as a group. Just explode it. Now run again. Now enter spacing 10. Now you can see the points are inserted exactly on the line at the given spacing. Now you can use this macro to insert points on polyline without selecting each polyline in the AutoCAD drawing. Now this video ends here. The next video we will create user form for user input and add additional options to select polylines from the drawing. And we are add more objects like blocks and text. If you like this video, don't forget to click like button, and if you are new to VBA, watch my previous videos to understand the VBA interface. And if you didn't subscribe to my channel, don't forget to subscribe for future videos and put your valuable comments on the comment box. Thank you. Thanks for watching. Goodbye.